Good morning, my dear students. Today, initially we focus on one of the important topics in physics by name collisions. On an average, every year, one question come right from this topic, collisions. Okay, every one of us know what do we mean by collision. While playing carom board there, striker goes and hits the coin. There's a collision. A bus collides with a lorry. That is a collision. A cricket ball striking the ground is a collision. So all these collisions can be classified into three types of collisions. They are perfectly inelastic collisions, perfectly elastic collisions, and semi-elastic collisions. PIEC means perfectly inelastic, PEC perfectly elastic, SEC semi-elastic collisions. Let whatever is the type of collision there, one point is confirmed that momentum of the system just before collision and just after the collision will remain constant there. So momentum of the system will always remain constant in any collision. So momentum remains constant in any type of collision, point number one. In some collisions, kinetic energy is conserved. In some collisions, kinetic energy is not conserved depending upon the nature of the collision there, which we discuss. Initially, we focus on perfectly inelastic collision. Before that, one main point from the earlier chapters we have to recollect. What do you mean by momentum? Momentum is a product of mass into velocity. So momentum is a vector quantity that always acts in the direction of velocity. Momentum is a vector that acts in the direction of velocity. Whereas kinetic energy means half into mass into magnitude of velocity square. So kinetic energy is a scalar quantity. So we have to recollect that momentum is a vector and kinetic energy is a scalar. Initially, we start with the perfectly inelastic collision. Okay. In the case of perfectly inelastic collision, the major point is that during the collision, the bodies stick together. Okay. Suppose there is a wet clay ball, another clay ball. They come and collide there. They combine into a single mass there, single entity. That particular collision is called as perfectly inelastic collision. So you can see M1, M2, before collision, they are separate, moving with velocities U1, U2. And after collision, they combine into a single mass, move with common velocity. As already we discussed, momentum is always conserved in a collision there. So initial momentum of system is final momentum of system. M1, U1, initial momentum. M1, U1 plus M2, U2 is final momentum. M1 plus M2 into V common. Special care need to be taken while writing and using this formula that velocity is a vector quantity. So we have put bars over the velocities there. So we have to keep in mind that velocity is a vector. Now, in this particular perfectly inelastic collision, there is a loss in kinetic energy there. What is the formula for loss in kinetic energy of system means? Loss in kinetic energy of system for perfectly inelastic collision when two bodies collide is half M1, M2 by M1 plus M2 into mod of U1 minus U2 whole square. So first you have to find U1 minus U2 vector there, find its mod, and half M1, M2 by M1 plus M2 into mod of U1 minus U2 whole square. That's the first step. Okay, then listen. The three questions under this perfectly inelastic collision should make you definitely thorough in this particular subtopic, please. A 6 kilogram body is moving with a velocity 3 meters per second east, undergoes one-dimensional perfect inelastic collision with another body, mass of the other body is not given, moving towards west with a velocity 2 meters per second. Okay, that particular data, first I want to show here there. So this is a 6 kg body. So this is a 6 kg body moving towards east with a velocity 3 meters per second, collides with another body of mass m2 moving towards west. This is moving towards east, this is moving towards west in the opposite sense. Okay, and this body is moving with a velocity 2 meters per second. Okay, immediately care is to be taken right at that step. If the east direction we take it as positive, west direction comes out to be negative. So this initial velocity is +3 because it is towards east. This is -2 because it is towards west. Now, if you concentrate on the next part of the wording there, they undergo one-dimensional perfectly inelastic collision. This is a key wording you have to catch in the exam. So what type of collision means? Perfectly inelastic collision, and this combined body moves with a common velocity of 1 meter per second. This combined body is moving with a common velocity of 1 meter per second, that too towards east. So these two bodies are undergoing collision. They combine into a single mass there. So what the mass of combined body means? 6 plus m2. This combined body, as per the question, is moving towards east with a velocity of 1 meter per second, 1 meter per second east. Already we know, east we take it as positive there. So the velocity of the combined mass is +1. For the last time, where we need to be careful, just the point I focus there. The initial velocity of first body is east. Initial velocity of second body is west. So u1 is positive, u2 is negative. Combined body is once again moving towards east. So east we are taking it as positive now. So common velocity of the combined body is +1. Now I want to know what is the loss in kinetic energy of the system. Okay, stick to the fundamentals. In any collision, momentum is conserved. Initial momentum of system is final momentum of system. Initial momentum of system means m1 u1 plus m2 u2 is equal to m1 plus m2 into v common. Okay, what is m1 u1 there? You know m1, you know u1. 6 into 3, that comes out to be 18. m2 u2, okay, m2 u2 is minus there, so minus 2m2 is equal to m1 plus m2 there. m1 plus m2 comes out to be 6 plus m2 into common velocity, that is 1. We have to simply solve this equation to get the value of m2 there. So 18 minus 2m2 is equal to 6 plus m2. If you bring minus 2m2 this side, this comes out to be 3m2 is equal to 12 there. 18 minus 6 equal to 12. So m2 comes out to be 4 kilogram. Okay, we have calculated the mass of the second body, which is not given, as 4. Next step is, he is not asking m2. He is asking, what is the loss in kinetic energy of the system? What is the formula for loss in kinetic energy of system? This comes out to be half into, after finding m2, substitute here, half, m1, m2 there. So you know that m1 is 6, m2 is 4. m1, m2 means 24. By m1 plus m2, that is 10. m1 plus m2, 6 plus 4, 10, into mod of u1 minus u2 whole square. So this is the point here there. You have to calculate u1 minus u2 vector there. What is u1? u1 is +3 minus of u2. u2 comes out to be -2. u2 is -2. Okay, these are all the, this is the step 2 and this is the step 3. Here I am writing the step 3 there. So u1 minus u2 is 3 minus of -2. This comes out to be 5. So what is the value of this? Mod of u1 minus u2 means it comes out to be 5 there. That particular square you do it. So this comes out to be loss in kinetic energy of system. If you just write here there, this is half into m1 m2 by m1 plus m2, 24 by 10 into, okay, then u1 minus u2, we got it as 5 there. So it comes out to be 5 squared. You can just simplify this particular thing there. You will get the answer in terms of joules there. So this is the thing here. Okay, pay attention. 18 minus 2m2 is 6m2 there. Yeah. Then 3m2 is equal to 12, m2 is 4, and these are the things. Going to the next bit. The previous question is one-dimensional perfectly inelastic collision. Now we are bothered about the two-dimensional collision. We are interested about the two-dimensional collision. Two bodies are of masses 6 kg, 12 kg. They are moving with velocities u1 given, u2 given. They are given in terms of ij. That means they are moving in a plane, two-dimensional collision. If they undergo two-dimensional collision, the two perfectly inelastically, I want to know what is the loss in kinetic energy of system. Okay, the loss in kinetic energy of the system, let it be one-dimensional or two-dimensional there. If the collision is perfectly inelastic between two bodies, loss in kinetic energy of the system comes out to be a simple half m1 m2 divided by m1 plus m2 into mod of u1 minus u2 whole square, as we have done now. So the point I want to just confirm you is that this formula is happily applicable both for 1D collision, 2D or 3D, any collision between two bodies if they undergo perfectly inelastic collision. Okay, now here you know the value of u1. Here you know u2 there. Okay, you calculate first u1 minus u2 vectorially. u1 minus u2 you calculate. So u1 minus u2 means 3i minus 9i. That comes out to be minus 6i. 4j minus of minus 4j. It comes out to be 8j. So you calculated u1 minus u2. u1 given, u2 given. You just substitute here. Then I want to calculate mod of this vector there. Mod of this vector. From vectors topic, we know how to calculate the magnitude of a vector there. This comes out to be under root of minus 6 square plus 8 square. It comes out to be 10. So mod of u1 minus u2, you know. Now, definitely you know the first mass m1, second mass m2 there is, you know, m1, m2. And you know mod of u1 minus u2 there. If you substitute, you will be getting the answer for loss in kinetic energy of the system for two-dimensional collision. Okay. The next question is perfectly inelastic collision in combination with a little bit of thermodynamics. The question says, two copper spheres are of masses 7 kg, 3 kg. Mass of first body, mass of second body are given. They are moving with velocities 6 meter per second east and 4 meter per second west. So if you write the data here, so mass of the first body is 7 kg, mass of the second body is 3 kg, and their velocities are, what the velocity of first body, u1 means 6 meter per second east. If you take east as positive there, that comes out to be plus 6 meter per second, and initial velocity of second body is 4 west, minus 4 meter per second. They undergo perfectly inelastic collision. Thereafter, you read the next sentence. If 50% of the kinetic energy that is lost in the collision is converted to heat energy, I want to know what is the rise in temperature of the combined block. Okay. First step is you calculate what is the loss in kinetic energy of system. What is the formula for loss in kinetic energy of system there? The two perfectly inelastic collision, half m1 m2 by m1 plus m2 into mod of u1 minus u2 whole square. In perfectly inelastic collision, this is definitely a probable point the examiners can pick up. Now, here it comes out to be half the product of the masses 7 into 3, 21 by sum of the masses 7 plus 3, 10 into mod of u1 minus u2 whole square. So you can calculate what is this u1 minus u2 means 6 minus of minus 4. So this comes out to be 10. So this is 10 square there. 110, 110 get cancelled. So you can just write it as half into 21 into 10. Intentionally, I have left it like this. We can simplify, let us not simplify. We better not simplify. Okay, now, what is the next part of the question there? This is the loss in kinetic energy there. Out of this loss in kinetic energy, 50% of this kinetic energy lost is being converted in the form of heat as per the given wordings in the question. So the second step here comes out to be point number 2. What is the heat energy developed means 50%. 50% means half of the kinetic energy lost. 50% means 50 by 100 equal to half. Okay, 50% of the kinetic energy loss is being converted to heat energy. Because of heat energy, temperature of the combined block will rise. I want to know what is the rise in temperature of the combined block. Okay, now, what is the heat energy that is being lost here? The heat energy that has been developed, half of kinetic energy lost. That means half of, okay, this kinetic energy lost comes out to be, again, another half there into 21 into 10. There's a kinetic energy being lost. This kinetic energy is being used this particular heat energy is being used to raise the temperature of the combined block there. Okay. What is the formula for heat energy responsible for rise in the temperature there? Heat energy responsible for rise in temperature is nothing but heat energy developed is mass of the combined body into specific heat into rise in temperature. Because of heat energy, whenever temperature of a body rises by delta theta, you know that heat energy responsible for rising the temperature is ms delta theta there. So mass of the combined body into specific heat of the body into rise in temperature. Okay, we are just writing here. What is the mass of the combined body there? 7 plus 3, 10. Here, you have to be very careful with this one. This specific heat is given in not SI system. This specific heat is not given in SI system. It is given as 0.01 calorie per gram per degree centigrade. This is the way specific heat is given. Definitely it is not SI. So the first and foremost thing here is convert this value into the SI system. 0.01. All of you know 1 calorie means 4.2 joule. 1 gram means 10 to the power of minus 3 kilogram degree centigrade. If you simplify these things, this comes out to be 42 joule per kilogram per degree centigrade. Just simplify there. It comes out to be 42. So this is the major step there where you have to take care about the specific heat being converted into the SI system. So mass of the combined body we have seen 10. Specific heat of the body comes out to be 42 into the rise in temperature is equal to half into half, 1 by 4 into 21 into 10. Why we did not cancel, why we did not multiply 21 into 10 earlier means you can see that there's a happy 2 there, happy 2. Okay, from this 10 can be cancelled. So the rise in temperature comes out to be 1 by 8 there. You must be knowing 1 by 8 is nothing but 0.125. So this is the answer for the question. Rise in temperature of the combined block is 0.125 degree centigrade. This is a combination of two important topics in first year physics. Okay, now touching some of the main points in perfectly elastic collision. In perfectly elastic collision, the main feature is that the kinetic energy of the system is conserved. First of all, the bodies will not stick together. Bodies will stick together in perfectly inelastic. In this perfectly elastic collision, the bodies do not stick together, but the kinetic energy of the system will remain intact. The kinetic energy of system before collision and after collision remains constant. Then see here. First, suppose there are two bodies of masses m1, m2. They are moving with some velocities u1, u2. Before collision, they move separately. After the collision also, they move separately because they don't stick. So the initial velocities are u1, u2, final velocities are v1, v2. So momentum of the system is constant. Initial momentum is final momentum. So m1 u1 plus m2 u2 is m1 v1 plus m2 v2. Care to be taken that velocity is a vector. There's a small but important point. And kinetic energy is constant there. So you can write half m1 u1 square plus half m2 u2 square is half m1 v1 square plus half m2 v2 square. If you simplify and solve these two equations, we get one of the very useful special relation of this perfectly elastic collision, that u1 plus v1 is equal to u2 plus v2. How can we remember? Means initial velocity and final velocity of first body is equal to initial velocity and plus final velocity of the second body. u1 plus v1 is u2 plus v2. Initial plus final of first body is equal to initial plus final of second body. Okay. Now, when you solve these equations there, we can get the formula for final velocity of first body after the perfect elastic collision. That v1 is u1 into m1 minus m2 by m1 plus m2 plus u2 into 2m2 by m1 plus m2. So one of the useful relation there. So perfectly elastic collision means you need not remember too many things there. Okay, these equations will do the job in a broad way. Okay. Now, to save our time, question and answer being displayed here, they say. Some students remember some standard conditions there without remembering the limitations of those statements. Okay, they remember something and as it is reproduced there without saying whether conditions are satisfied or not. So this particular question tells a lot about such situations there. Listen, a ball of mass 20 gram is moving with a velocity of 8 meters per second. A ball of mass 20 gram, so you can see here there, is moving with a velocity of 8 meters per second towards east. East we are taking it as positive plus 8. This ball is undergoing collision with a massive wall there. Okay, this ball is colliding with a huge wall, massive wall. The wall is not at rest. So the imaginary case that the wall is moving directly towards the ball with a velocity of 5 meters per second. So by now we have understood that it is a collision between a very lighter body, okay, 20 gram lighter body with a massive wall. Collision between a lighter body and very heavy body. But here the very heavy body is not at rest. It is in motion there towards the ball. So since we have taken the right side velocity as positive, the left side velocity comes out to be negative there. So this u1 is plus 8 and u2 is minus 5. They are moving towards each other in the opposite directions. One is plus, other one is minus. Okay, now I want to know what is the final velocity of the ball after the collision. Okay. Here, the main concept we need to use is that whenever a very heavy body is being collided with a light body, the velocity of the heavy body remains almost unchanged. I repeat again, whenever a very heavy body is undergoing collision with a lighter body there, the velocity of the heavy body remains unchanged. So there's a very heavy body there moving towards the lighter body. So velocity of the heavy body remains constant. That means its initial velocity is 5 meters per second towards left, that is minus 5. Final velocity is also minus 5. There's a major point that is being highlighted there. Okay, the final velocity of this body is same. Just now we have seen, whenever we come across perfectly elastic collision, we can use that cute formula. U1 plus V1 is U2 plus V2. Okay, here U1 is 8 there, 8. V1 we want to know. U2 is minus 5, V2 is minus 5. If you do it, V1 comes out to be minus 18. What does the minus 18 says? Plus sign for velocity says east, minus sign says west. So 18 meter per second towards west, please. Okay, 18 meter per second towards west. This is a small bit, but it is not a general situation there. Remembering some general formula and using the general formula, you get anyone will get a slightly wrong answer there, and you need to be slightly careful about the situation that is being given. Okay. The next bit says a sphere of mass this question has come many times in the exam. A sphere of mass 2 kilogram is moving with a velocity, and what velocity is not telling, certain velocity, collides elastically. Elastically means perfectly elastically with another sphere at rest. Mass of the second sphere is not given, but it is said that it is at rest. If after the collision, the first sphere moves in the same direction with its velocity reduced to 1/3 of the initial velocity, find the mass of the second sphere. Okay, now see, a sphere of mass 2 kilogram is moving towards the, let us say, right, with certain initial velocity, let us say u. It is colliding with another sphere of unknown mass, but at rest. U2 is 0. So M1 is given. U is, we are assuming U1 as U there. Second mass, not known, but it is at rest. What is given the question? After the collision, velocity of this body is reduced to 1/3 of the initial velocity, but moving in the same direction. So V1 is U by 3, and the 2 moving in the same direction is said. This is plus means this also comes out to be plus. Then the second mass is unknown there, you have to calculate. So if you remember the formula which we were discussing, V1 is U1 into M1 minus M2 by M1 plus M2 plus U2 into 2M2 by M1 plus M2. Here the happy thing is that this U2 comes out to be 0. So this term will vanish. So you write V1 is U by 3, U1 is U. So in this particular formula there, the M2 is the only unknown term. If you solve it, M2 comes out to be this one. At least in every entrance examination system there, 20 to 25% of paper will have an easy question like this. Pay attention. So these things we discussed there. We'll go for some combination of questions afterwards, after we have some idea about semi-elastic collisions. Okay, in the case of semi-elastic collision, once again, bodies do not stick together. Bodies won't stick together. So just before collision, their velocities are U1, U2. After the collision, they don't stick. They move separately with velocities V1, V2. Before collision, they move separately. After collision, they move separately. No sticking. So momentum of the system is conserved. Initial momentum is final momentum there. So M1 U1 plus M2 U2 is M1 V1 plus M2 V2. Okay. Here, there is a special wording that come into picture there. Coefficient of restitution, with which you are well aware of. In what way? Coefficient of restitution, this final velocities and initial velocities are related means V2 minus V1 is E into U1 minus U2. Once again, remembering that velocities are vectors. Okay, this formula you have to be thorough with. If you solve these two equations together, you get slightly a lengthy formula. V1 is equal to U1 into M1 minus EM2 by M1 plus M2 plus U2 into M2 plus EM2 by M1 plus M2. Okay, definitely a solvable equation, but you have to remember and reproduce it. There's a formula for V1. And what is the formula for kinetic energy lost during this semi-elastic collision? During this semi-elastic collision specifically, kinetic energy loss in the system is half M1 M2 by M1 plus M2 into mod of u1 minus u2 whole square, once again multiplied by 1 minus e square. So suddenly, one of the slightly longer formula in 2S physics. So kinetic energy loss in semi-elastic collision comes out to be half m1 m2 by m1 plus m2 into mod of u1 minus u2 whole square into 1 minus e square, where e is a coefficient of restitution. And so these are the three formula that will totally rule this topic. Okay. Now, we are seeing this particular thing there. A body of mass 4 kilogram collides with a stationary body of mass 1 kilogram. A body of mass 4 kilogram is colliding with a stationary body. Its velocity is 0, but mass is 1 kilogram. So there is a body of mass 4 kilogram. Let us say that it is moving at velocity u, colliding with a stationary body of mass 1 kilogram. The collision is said to be semi-elastic collision of coefficient of restitution E there. Find the ratio between their final velocities. Okay, now comes the advantage of the formula we were remembering there. So just in the previous slide, we have seen that the velocity of this particular body comes out to be, just 1 second here. Yeah. So final velocity of the first body is u1 into m1 minus em2 by m1 plus m2 plus u2 into this one. Here, in this particular question there, the second body is at rest. This term will vanish there, this term will vanish, and this is the term left over. So you can just remember that v1 is u1 into m1 minus em2 by m1 plus m2. Okay, now going for the question here there. So if you recollect the formula for v1 there, v1 is u1 into m1 minus em2 by m1 plus m2. The formula will continue with the plus u2 into something, but the term comes out to be 0, as already explained. Okay, so here you have to calculate the final velocity of first body. Final velocity of first body means initial velocity of first body into m1 minus em2. That means 4 minus e into m2 comes out to be 1. m2 is 1 by m1 4 plus m2 1. So this is the value of u. v1 is equal to u into 4 minus e divided by 5. That's a step number 1. What is the step 2 there? We want to know what is the ratio between the final velocities of the two bodies. Final velocity of the first body, we got it. Now we have to calculate final velocity of second body. How to calculate the final velocity of second body? So once again, if you recollect the formulae properly, is in the exam system, you have to recollect them very quickly and efficiently. v2 minus v1 is equal to e into u1 minus u2. Here, you know u1, you know u2, already given. And v1 we have found. From that, you have to calculate v2. From this equation, you have to calculate v2. You know v1 and v2. He is asking, what is the ratio between the final velocities, v1 by v2? Okay. Once again, I re-repeat that in 2026 recently conducted exam there, many of the questions, at least 80 to 85% of the question paper has this standard or even comparatively easier standards there. So doing all these questions efficiently should give you a very, very better score. Okay, the previous question, we definitely need to call it as substitution bit. Almost nothing is there. But right in this particular question, there is something here there. So for such questions, you please write something like logic. You have to adopt a proper method for the question, their method. So why I have done the previous question means, let me tell you again. So that is almost a direct question there. And once I re-repeat that, such direct questions are common in your exam. At the same time, few questions will decide the better rankers list there. And for that, this particular question will do the job. A body in motion undergoes one-dimensional semi-elastic collision with an identical body, which is initially at rest. So both the bodies are identical, masses are same. Okay, a body in motion, he said. So this is moving like this. Let us say with some velocity u. A body in motion. This is a body of mass m, moving with some velocity u, and it is colliding with a second body which is at rest. U is 0. He said loss in kinetic energy of system is 30% of initial kinetic energy of system for the coefficient of restitution. So that slightly lengthy formula, you have to recollect a little properly there. What is the formula for loss in kinetic energy of system for semi-elastic collision? That comes out to be half into m1 m2 divided by m1 plus m2 into mod of u1 minus u2 whole square into 1 minus e square. Okay. What is the loss in kinetic energy of system is this one. He said that the loss in kinetic energy of system, this loss in kinetic energy of system is 32%, 32 by 100 of the initial kinetic energy of system. That's what said. So slightly lengthy bit. Okay, the 32% means 32 by 100 of initial kinetic energy of system is, you have to write these things, half into m1, m2 there. Both the bodies are of same mass. So m into m square, m1 plus m2, 2m, u1 minus u2 whole square, that is u square, into 1 minus e square. Okay. Now, I want to know what is the initial kinetic energy of system. This is the initial case. Initially, second body doesn't have any kinetic energy because it is at rest. The first body is the only body that has kinetic energy. So initial kinetic energy of system is kinetic energy of the first body there, that is half into m into u square. So half into m into u square, second body is at this one. This m can be cancelled. This is half into m by 2 u square into 1 minus e square. So we did not get frightened with such a slightly lengthy thing. Happily, this mu square by 2, mu square by 2 get cancelled. Then if you bring 2 here, there. Okay, I want to just show you that it is on simple. This is simple only. So this is 64. 2 if you bring here, 64 by 100 minus is equal to 1 minus e square. So if you bring here there, e square comes out to be 1 minus 64 by 100. So e square is nothing but 36 by 100. Our idea is to calculate e there. So e comes out to be 6 by 10 or 0.6. That's the answer for the question. Okay. Now I said what extra logic they can go for. What extra logic they can go for. In this particular question, it is a little bit straightforward there. But the thing is, instead of saying that loss in kinetic energy of system is 32% of initial kinetic energy of system, they may say that the final kinetic energy of system is 68% of initial kinetic energy of system. This particular statement can be, instead of giving like this, they may interpret in a slightly different wordings, but meaning the same. Instead of saying loss in kinetic energy, 32% of initial kinetic energy of system there, they can say final kinetic energy of system is 68% of initial kinetic energy of system. So final kinetic energy left over is 68% means how much is the lost? Final kinetic energy left over is 68%. Left over is 68% means remaining. That means 100 minus 68, 32. That is being lost. So they may say that 32% of kinetic energy is being lost, or they can say that 68% is being retained. Both mean one and the same. If this wording is given there, okay, you have to convert the data to this one and get the answer this way. And that particular question will be one of the very good quality question if it comes. Okay, pay attention. So now, collision of a rubber ball with the ground. Under the heading of collision of rubber ball with the ground there, a rubber ball is freely released from a height of 324 meters. The original height from which the rubber ball is freely released is given 324 meters. If it rebounds to a height of 4 meters after the second collision, all of you know, when you freely release a rubber ball there's a collision number 1, and it goes like this, collision number 2. After the second collision, the height to which it rebound after the second collision is 4 meters. Then I want to know what is the coefficient of restitution. Okay. A rubber ball is freely released from a height of 324 meters. The original height from which the rubber ball is freely released is denoted by symbol capital H. Capital H is the original initial height from which the rubber ball is freely released, 324. Okay, everyone knows when you freely release a rubber ball from some height, after the first collision it goes to some height. After second collision, lesser height, and so on. So after second collision, it is going to a height of 4 meters. Height to which it rebound after second collision is H2, that is equal to 4. With this, I want to know what is the coefficient of restitution. If you recollect the formula there, height to which a rubber ball rebounds after the nth collision is equal to e to the power of 2n into h. One of the important sub-corners examiners are generally interested in this topic. The height to which the rubber ball rebound after the nth collision is e to the power of 2n into capital H. Height to which the rubber ball rebound after the second collision there is equal to e to the power of n is 2 now. E to the power of 2n means 4 into capital H. Okay, the next point. Now, if you happen to see height to which the rubber ball rebound after the second collision is 4. Okay, given as 4, e to the power of 4 into 324. Okay, now without any confusion, you should be able to solve the equation for E there, even though it is e to the power of 4. So e to the power of 4 is nothing but, common number of you, 4 by 324. Okay, at the earliest, cancel if you can simplify them and cancel them. So this comes out to be 1 by 81. So 324, make it simpler. Now, e to the power of 4 is 81. Take square root once. Take square root for the first time. So e square is equal to 1 by 9. Square root of 81 is, take square root again. So e is equal to 1 upon 3. So the coefficient of restitution is 1 by 3 or 0.333 in decimals. Once again, formula recollection and doing the simple algebra arithmetic in a peaceful way. Yeah. The next question says, this model already I have explained there. See, now this is the other question where slightly careful you should be at one stage of the question. A rubber ball is freely released from a height of 80 meters. So this question is basically a combination of little kinematics. There is a collisions part there, and there is a little bit of importance of even the vectors. Maybe a combination of 3 small topics there. Even then, it is an easy and always an important model. A rubber ball is freely released from a height of 80 meters. Very good. Coefficient of restitution is given as 0.25. That is 1 by 4. Find the change in velocity of the rubber ball there during its first collision with the ground. So this rubber ball is first time colliding with the ground there. So when it collides with the ground, its velocity is bound to change. The velocity will change. I want to know what is the change in velocity of the rubber ball during its first collision with the ground. Okay. Now, the first point is, from the simple principles of kinematics there, any body freely released from a height ha will strike the ground with some velocity. Any body freely released from a height h will strike the ground with a velocity. You know that this velocity of striking, so we can call it as v1 there, is equal to root 2g into h. Any body freely released from a height h strikes the ground with a velocity v is equal to root 2gh. Okay, so this comes out to be 2. G is given as 10. Height is 80. This comes out to be as much as 40 meter per second. This is the velocity with which it is striking. Okay, now the rubber ball is rebounding there. Now, we use kinematics a little bit. Then comes the collisions concept there. Whenever a rubber ball collides with a massive ground there or massive earth there, then coefficient of restitution is being defined as the rebound speed divided by striking speed. So this is the collisions part you have to use after using kinematics here. Okay, so coefficient of restitution whenever a rubber ball collides with the ground is E is equal to rebound speed by striking speed. So coefficient of restitution is given as 1/4. The rebound speed, we don't know. Striking speed is 40. From these things, rebound speed comes out to be 10 meter per second. 40/4 equal to 10 meter per second. Then comes the little bit of point where you have to be careful. So the rubber ball is striking the ground with a velocity of, already we have seen here, 40 meter per second. And the same rubber ball is rebounding with a speed of 10 meter per second. That means it is striking with 40 and rebounding with 10. What is the change in velocity? What is the change in velocity? The major point you have to recollect is that velocity is a vector quantity. So for every vector, magnitude matters and direction does matter. Okay, so here this velocity is downward. Here the velocity is upward. Okay, for example, we are taking a upward direction as positive. Then downward direction comes out to be negative. So whenever you are involving vectors with opposite directions there, one direction you assume positive, opposite direction naturally negative. So let us say upward is positive. Say means assume. Upward is positive, downward is negative. So here, this is upward velocity. So this comes out to be plus 10. This is downward velocity. So this downward velocity comes out to be minus 40. Downward is negative, minus 40. What is the change in velocity there? Change in velocity is nothing but v2 minus v1 there. So v2 comes out to be 10. So remember that velocity is a vector. 10 minus of minus 40. 10 minus of minus 40 comes out to be what? Come on, tell me. 50. 50 meter per second. Okay. Little care will give you happily plus 4 marks, and you know the value of plus 4 marks, a huge lead over others. Pay attention. A rubber ball is freely released from a height of 20 meters. Okay, we have this particular thing being displayed right here, there, along with the question and answer there. Let us just go for it. See. A rubber ball is freely released from a height of 20 meters. Rubber ball freely released from 20 meters. Coefficient of restitution between the ball and the ground is 0.5. Okay. Whenever the rubber ball collides with the ground there, you know that it undergoes infinite number of collisions before it comes to rest. Considering infinite collisions before it comes to rest, we want to know what is the total distance covered by the body, what is the total time taken for all those collisions, and what is the average speed of the ball during all these collisions. This is a evergreen question there. Examiners over the years do like the bit there. One very common bit right in this particular exam system. Okay, A rubber ball is freely released from a original height of 20 meters. Clearly given the question there. The rubber ball freely released from 20 meters. Coefficient of restitution between the ball and the ground is given as 0.5. E is given as 0.5. The rubber ball collide first, bounces back, again collide, bounces back, collide, bounces back. So under ideal situations there, that means there is no friction at all, there is no air resistance at all. So the rubber ball will undergo huge number of collisions there, and for all those huge number of collisions, what are the distance covered? Everyone knows distance covered is defined as the actual path traced. So this path, okay, distance covered is the actual path traced there. So this comes to be this path, this path, this path, this, and so on. All these paths you have to add. So really adding them in the exam situation is definitely difficult there. You have to remember and reproduce the formula there. So this formula must be there in your good short notes. And the total distance covered by the rubber ball for all these infinite collisions comes out to be h into 1 plus c square divided by 1 minus c square. H into 1 plus c square by 1 minus c square. So you know the value of h20. You know that coefficient of restitution is 0.5. That means half. So E is half means E square is 1 by 4. So you know the value of H, you know the value of E square there. Simplified. It comes out to be 100 by 3 meters. This is the total distance covered by the body. Okay, I want to know what is the total time taken by the body for these infinite collisions. Okay, to calculate both total distance and total time, you get something like infinite geometric progression wording. So time will not be sufficient to do that progression so on. So you have to remember the formula. You have to remember the formula. So total distance covered and total time. So total time comes out to be t into 1 plus c by 1 minus c. So what is t there? T means the time taken by the rubber ball to collide with the ground after it is freely released. T is the initial time taken by the rubber ball to collide with the ground after its free release. Okay, once again from kinematics, you know that whenever a rubber ball is free released from a height h there, what the time taken for it to strike the ground means, this t comes out to be, which t means this is the time taken by the rubber ball to collide with the ground there. That t comes out to be root 2h by g. Or use the formula S is ut plus half it square, you do get the same. So the time taken by the rubber ball to strike the ground for the first time comes out to be t is under root of 2h by g. So the t comes out to be which time? This particular time. So the 2 into h comes out to be, h is given as 20 by g. So this t comes out to be 2 seconds. So in the total time there, the total time taken, capital T means this is capital T. So I repeat again. So for this particular part of the motion, the time taken is t into 1 plus c by 1 minus c. T you know 2 seconds, E you know. If you simplify this, it comes out to be 6 seconds. So this point is being written here also. Then I want to know what is the average speed. From kinematics, the fundamental definition of average speed is total distance covered by total time taken. You know total distance 100 by 3, total time 6 there. And if you simplify there, you get this answer. So one fundamental model worth revising from your side there. So I'm sure you're using the time and do well, my dear students there. Okay, all the best. Bye-bye.